Bismillahirrahmanirrahim. Assalamu alaikum, students. In the last lecture, I gave you the introduction to the syllabus. So, in today's lecture, we will go into the details of the syllabus. So, we will start with the unit first. Remember, our unit first is named as electrostatics. So, we start this unit today. So let me take my marker, use this color. Now, as I told you, electrostatics is that branch of physics which deals with the study of charges at rest. When we say charges, by that we mean the particles which have charge or bodies which have charge, and that charge is assumed to be at rest in electrostatics. And when we discuss all the phenomena related to charges at rest or charged particles at rest, we say we are studying electrostatics. Now, it is not necessary that charges are at rest perfectly. They can be moving, but if the motion is small enough, if it is ignorable, still we talk of electrostatics. So the first idea which I have to discuss in this unit is the electric charge. What is electric charge? Now, if you see, the world around us is full of electric charge. Our body contains charges. My pen, which I am using in writing this text on this my viewboard, this contains charges. My clothes are full of charges. So there is enormous amount of charge in our tangible world, in our physical world. But when we say a body is charged, in most of the cases, what happens? The positive charges and negative charges, which are available in any body or in our physical or tangible world, they get cancelled out. So we say bodies are neutral. But when this charge imbalance takes place by some means, we say this body has some net charge. For example, if I have a glass rod, if I have a glass rod and I rub it with slick, what I do, I rub glass rod with silk, rubber with slick. So what happens when I rub this glass rod with slick? The charge neutrality of this glass rod is disturbed because the process of rubbing transfers a tiny amount of charge from one body to the other. That is, from glass rod and slick, there is between glass rod and slick, there is transference of charge. Now, what happens? The charge created on this glass rod we conventionally call positive charge. So there is some positive charge created in this glass rod. So what happens actually? Some of the electrons from this glass rod move to the slick when we rub glass rod with the slick, right? And by convention, electron is a negatively charged particle. So the deficiency of electrons in the glass rod is labeled by convention as a positive charge. Another thing, if you take plastic rod, if I have a plastic rod and I rub it with fur, rubbed with fur. So if I have a plastic rod rubbed with fur, again by rubbing the charge neutrality of both the objects, both the bodies, plastic rod and fur, that charge neutrality is disturbed because the transference of electrons takes place. Now, the charge created in the plastic rod by convention is called negative charge. That means you can understand that some of the electrons from the fur enter into this plastic rod. So it has a net negative charge. So rubbing transfers particles. Fundamentally, what happens? The electrons are moved from one body to another. And remember, uh, in the earlier days, we thought of this kind of electricity as frictional electricity. Because at that time, people were thinking that there is something in the rubbing which creates the property of electric charge, which creates the property of electricity in the body. So there is something in the friction. So they called it frictional electricity, right? Right now we know the electrons are present in the bodies and they move by rubbing. So the transference of electrons from one body to another body is what creates the charge imbalance. Some bodies are positively charged, which lose electrons, and some bodies get negatively charged, which gain electrons in the process. So it is not just friction, there are other means create this positive charge and negative charge in bodies. Now, if you hang this glass rod rubber with slick by some thread, there is some thread and you bring another glass rod. Let me make it a bit clear. You take another glass rod. This is my another glass rod, rubber with slick, right? So again, it has also positive charge because I am rubbing it with slick. So what will happen? These two glass rods will repel each other. You will see they push each other away from each other. So there will be force F on this glass rod and there will be same force on this particular glass rod but in opposite direction. We draw it here and name it minus F. By minus I mean the magnitude of these forces is equal but this direction is opposite. The two glass rods rubber were slick repel each other and because of this force this rod may rotate about an axis, right? And if you bring this plastic rod, there will be different situation. If I have now this glass rod, first I have glass rod rubbed with use another color. This is glass rod rubbed with slick. So it has positive charge. Now I have plastic rod rubbed with fur. This is my plastic rod rubbed with fur. So it has negative charge in it. What will happen? They will attract each other. If you do this experiment, will pull this rod with F and negative F will act on the plastic rod rubber with far. So there is attraction. When it attracts it, it will rotate in opposite sense compared to first situation, right? It was pushing it, it rotated this way. Now plastic rod is pulling it, so it will rotate this way. So these experiments can be summed up. There are no other possibilities. So I should tell you, if you create charge in any body by any means, right, you will get always these two situations. Either the two bodies which are charged, they repel each other or they attract each other. So we say there are two kinds of charges. The rule is, or conclusion is, that charges are of two kinds. One is called positive and second is called negative, right? The charge on the glass rod, which is rubbed with slick, is positive. The charge created in the plastic rod, which is rubbed with fur, is negative. Now, the interactions because of these two kinds of charges, the interaction is of also two types. Charges of the same sign repel, write it. Charges of the same sign repel each other, and charges of the opposite sign attract each other, right? Charges of the same sign repel each other, and charges of the opposite sign attract each other. Sometimes we say like charges repel and unlike charges attract. That is the equivalent way of saying the same thing. So one glass rod rubbed with slick will attract the plastic rod rubbed with fur because the charges are unlike, they are opposite in sign. But if you take glass rod rubbed with slick closer to another glass rod rubbed with slick, or plastic rod rubbed with fur closer to another plastic rod rubbed with fur, there will be repulsion because the charges of the same sign repel, or like charges repel. The like charges repel each other. So we have the conclusion is now that charges are everywhere, but in most circumstances, there is enormous amount of charge, right, in each body. But normally those charges get cancelled out. But when we do some process, we say we have created charge. Fundamentally, what we do, we create a charge imbalance in the body. The charge and neutrality is disturbed and charge is created, right? And if you compare the amount of, we call sometimes it excess charge or net charge created in this glass rod or plastic rod or any other body, that amount of charge which is created is a small fraction of the total charge available in the body. I repeat, the amount of the charge created in a body is a small fraction of the total charge present in the body. Now, because it's this charge, as you have observed, because of this charge, bodies have some properties. For example, if the glass rod is neutral and you take another glass rod rubbed with slick nearer it, there will be no interaction, tangible interaction. There will be no repulsion of this kind. Or if you take two glass rods closer to each other which have no charge, no net charge or excess charge, there will be no interaction. So it is the possession of the positive or negative charge in a body due to which it shows interactions like charges repel or unlike charges attract. First they must have charge. After that they will show these kind of interactions, right? Another example you can take at smaller level. If you take a sodium atom, it is sodium atom, its atomic number is 11. That means its nucleus contains 11 protons and the extra nuclear part contains 11 electrons. When it is neutral, that means when there is no net charge or excess charge. Remember, the charge on the electron is magnitude wise same as that of proton, but it is negative. So in this atom, there is a positive charge in nucleus and there is extra nuclear part. Now this nucleus contains 11 protons. One proton has 1 e charge plus 1 e charge, that is plus 1.602 into 10 raised to power minus 19 coulomb. E stands for this value. An electron has minus e charge, which is minus 1.602 into 10 raised power minus 19 coulomb. So this atom contains 11 protons in the nucleus. So total positive charge is plus 11e, and in the extra nuclear part there are 11 electrons. So the charge due to the electrons in the atom is minus 11e. So the total charge in the atom is 0. So if Q represents the charge of sodium atom, it is 0. Because this charge has the property of additivity. By that I mean, if you have to find the total charge in some object or body or atom or ion, you have to see all the elementary charges in it and algebraically sum them to get the charge of that object. Then the sodium atom plus 11e positive charge minus 11e negative charge cancels out. Total charge of the sodium atom is 0. Similarly, if you take chlorine atom, for example, chlorine atom, its atomic number is 17. Now you can understand it was here, that was 11. The atomic number of sodium is 11. Atomic number of chlorine is 17. So its nucleus contains 17 uh, protons and the extra nuclear part contains 70 electrons. So the total charge of the chlorine atom is 0. So if you take chlorine near sodium atom, there will be no bond formation. Then what happens? First they possess this charge. So what happens? Chlorine becomes chlorine negative. By chlorine negative, we mean it has gained an electron. That means now its extra nuclear part contains 18 electrons, but the nucleus contains 17 protons. So the net charge is minus E. And what happens in case of sodium? It becomes sodium positive. Sodium positive means it is that sodium atom which has lost one of the electrons. When it loses one electron, then total charge becomes of that one proton. Why so? Because the nucleus contains plus 11 protons, extra nuclear part contains 10 electrons. So plus 11e minus 10e becomes plus 1e. That is indicated as Na positive. Now Na positive and Cl negative are two unlike charges, so they attract. That is how sodium chloride molecule formation takes place. So this was just an example how the possession of charge leads to interactions. Sodium atom and chlorine atom, and they are neutral. There is no charge imbalance in them. They will not get connected with each other due to electrical interaction. But when they acquire charge, unlike charges this way, there is charge imbalance in them. Now they have the excess charge or net charge. So that leads to interaction between them. So it's just like bodies have mass, and due to mass, they possess or show some interactions like they show inertia or they gravitate. Similarly, when bodies have charge, due to that charge, they show certain interactions, right? Now, this electric charge has certain properties. First one we have discussed. So let me use some other color. Let me use green. So properties of electric charge. First we discuss is additivity. Additivity we discussed that if we have a body which contains charges, now we want to find the net charge, we have to add up all the elementary charges algebraically. By algebraically I mean you have to take in the sum positive charge as positive term and negative charge as negative term. For example, in case of this sodium atom, when I find charge, it is plus 11e minus 11e. So it becomes 0. But in case of sodium positive, when I find charge, it is plus 11e but minus 10e because it has lost one electron. So its charge becomes plus e plus 1e, right? So this additivity property holds for electric charge. To find the charge in the net charge in a body, you algebraically add all the charges in it. Second property is conservation. Charge is conserved. Charge is conserved. Like total energy. You know the total energy of the universe is conserved. That means you cannot create or destroy energy. If you create energy in some portion of the universe, that amount of energy must disappear somewhere else because the total is conserved. Similarly, the charge is conserved also. For example, when I say some amount of positive charge is created in glass rod, that amount of positive charge must disappear in the other object, that is the slick, right? And similarly, when I say this charge is created in plastic rod, this negative charge that must disappear in fire, right? Because the total charge is conserved. Remember, actually, electron transference takes place. So if a body loses 10 electrons, other body gains 10 electrons. So the gained electrons in one body disappear in other body because the total number is conserved. So electric charge is conserved. This has no exception at any level, and this charge conservation is used to uh, rule out some nuclear reaction or chemical reaction. If any chemical or nuclear reaction or any kind of phenomena it doesn't obey charge conservation, we say it cannot occur in nature. For example, you know there is an event called phenomenon, you can say called peer production. It conserves charge in peer production. What happens? A gamma ray photon is a gamma ray. Let me write it clearly. Let me write the first reaction. Gives an electron and a positron. This uh, reaction, a phenomenon is called pair production because a pair of particles is produced in it. Let me write it. This is a symbol for gamma ray photon. Gives what? E minus means electron. E positive means here positron. Positron is antiparticle of electron. By that I mean positron has the same mass as that of the electron, but its charge is opposite in sign to electron. That means electron has minus 1 E, positron has plus E, same charge as proton, right? Photon has no charge. Gamma ray photon means the photon which belongs to gamma ray zone of electromagnetic spectrum. So it has no charge. So if you see here on the left hand side, charge is 0. On the right hand side, this has minus E and this has plus E. So total charge on the right hand side is 0 as well, right? Charge is conserved. Charge is conserved in any kind of process which occurs in nature. This was just an example. Similarly, we have pair annihilation, reverse process of this, which is called pair annihilation, in which what happens? Pair of particles disappears. We have electron, it combines with positron, and we get two gamma ray photons, right? So charge is conserved here. Q for this photon 0, for this photon 0. Q total on the right hand side is 0. Here you have Q minus E for electron, Q plus E for electron, and Q total is 0, right? So don't get confused. Oh, here we have one gamma ray photon giving electron and positron, and here electron and positron combine to do two gamma ray photons. This pair production happens near some nucleus when gamma ray photon is going in the neighborhood of some nucleus. Then we have another rule that's called conservation of momentum. So to conserve conservation momentum and the total energy in the process, these events take place this way, which I have shown here. So the point is here, the electric charge is conserved in any process, right? So this is second property of the electric charge. So let me move to third property. The third property is the quantization. Quantization. Electric charge is quantized. Electric charge is quantized. What is the meaning of that? The meaning of that is we write it first, then I will explain. Any charge Q that can be that can be observed and measured directly can be written Q equals NE, where N can be 0, plus minus 1, plus minus 2, plus minus 3, and so on. And E is the elementary charge, which is the symbol for this value 1.602 in the 10 raised power minus 19 coulombs. So this thing means the quantization. I'm saying any charge which can be observed and measured will satisfy this relation. That means if you measure charge of a neutral body, then n is zero. Its charge is zero. Now, if you measure the charge of some glass rod or plastic rod, it will always fall in this equation. That means it is either can be plus 1e, plus 2e, plus 3e, or negative can be minus e, minus 2e, minus 3. It cannot be 2.3e. It cannot be minus zero point 0.5e when you measure the charge of any object directly, right? Why so? Because it is quantized. Now, what is the quantization? Quantization means the physical quantity in question uh, behaves this way, that some small amount is possible, then all higher values are the integral multiple of that small value. Now, the smallest possible value which that object can have when it exists is called the quantum of electric charge. So, the smallest amount of charge, whether it is positive or negative, which a body can have when it is charged, is E. So, this E is quantum of electric charge. Quantum of electric charge is very small. All higher values are integral multiple of that. That means all higher values of charge are integer multiple of this. Either they are twice this, thrice this, four times this, or minus one times this, minus two times this, or minus three times this, and so on. So whenever any physical quantity behaves this way, it exists in nature this way, that there is some smallest unit possible, which is called quantum of that particular quantity, and all higher values are integral multiple of that. We say this quantity is quantized. So electric charge is quantized. Now, don't get confused. Some people get confused with this quantization. They say there is no quantization when they talk of the internal structure of protons or electrons. Remember, the protons, not electrons, sorry, protons or neutrons. Remember, protons and neutrons make up the nucleus, and they are made up of quarks. And quarks, the charge assigned to quarks is the fraction of E. For example, we say we have two kinds of quarks with reference to charge. We say up quark and down quark. Now, the charge of the up quark and down quark, they are fractional values. We have plus 2 by 3e, we have minus 1 by 3e, plus 2 by 3e, and minus 1 by 3e. So we say a proton is made up of proton has total E. Proton is made up of three quarks, two up quarks, and one down quark. And neutron is made up of three quarks, two down quarks, and one up quark. Right? Two down quarks, and we add up the charge with the additivity. Neutron has no charge because there are two down. So for neutron, you see Q will be 1 up quark plus 2 by 3e, then 2 down quarks minus 1 by 3e minus 1 by 3e. So the total, because minus 2 by 3e becomes 0. And in case of proton, you have 2 up quarks, so plus 2 by 3e plus 2 by 3e, then you have 1 down quark minus 1 by 3e. So the total is, it becomes 4 by 3 e plus minus 1 by 3, that becomes 3 by 3, which is e plus, right? Because proton has overall charge of plus, neutron has overall charge 0. So don't get confused with this scheme of charge case of quarks, because we have not isolated quark. We measure, when we say directly measured, we measure the charge of the proton directly, which satisfies this relation, right? So there is no issue with this. Quarks have not been isolated from the protons or neutrons. We know they are there, they have this much charge, but when we state this quantization of charge idea, we see the charge that can be observed and measured directly, right? So there is no issue with the quantization. Now, even if we isolate in future quarks from these elementary particles, protons and neutrons, still there is no issue. Then we have to change this equation. At that time, our quantum of charge will become 1 by 3, right? Because 2 by 3 can be written as the integral multiple of 1 by 3. All higher charges can be then written as integral multiple of 1 by 3. So we will have to change this equation. Quantum of charge will become smaller. So there is no issue. So these are the properties of the electric charge. So let me summarize my lecture before stopping. So charge is of two kinds. Because of that, there are two kinds of interactions. In case of electric interaction, we have repulsion. Like charges repel, unlike charges attract. Then electric charge, uh, when bodies possess electric charge, they show certain properties, they show interactions. Then there are three properties which we discussed in relation to electric charge. Electric charge has this property of additivity. To get the charge of a body, we have to algebraically sum all the elementary charges in it. Charge is conserved. In any reaction, nuclear, chemical, or any kind of phenomenon, charge is conserved. Total charge is conserved means if some charge appears somewhere, same amount must disappear somewhere else. And charge is quantized. Charge exists in this way that it has the smallest value of charge which we directly observe from an object is 1.602 in 10 to the minus 19 coulomb. All higher values are integral multiple of this, and there is no issue with the internal structure of protons. We said that inside protons there are quarks. Proton is composed of three quarks, two up, one down. Neutron is composed of three quarks, one up and two down. Down quark has minus 1 by 3 charge assigned, and up quark has plus 2 by 3 charge assigned. There is no issue with this quantization idea, because we have not isolated quarks. Even if we isolate them, still quantized charge is quantized, but we have to change this equation. Quantum will become then 1 by 3. Right now it is E. I hope it is clear to you. So let me stop here. Don't forget to like, share, and subscribe my channel. Thank you. God bless you. Assalamu alaikum.